So we stopped last time at this point in B of the question. They tell you this, and again, the way he had the question is a little bit different, but he tells you in B, what if xy is y? Can you evaluate the integral? So he's telling you if this is y, and you know that y in polar coordinate is r sine theta. So if I'm integrating y r dr d theta, then I'm integrating r sine theta times r dr d theta, and 0 to cosine, and 0 pi over 4. Okay, I'm gonna read some of this. So it's r squared sine theta, r squared sine theta dr d theta, 0 to cosine theta, 0 pi over 4. We integrate this with respect to r. Sine theta is a constant, so it's r cubed over 3 sine theta. You plug 2 cosine theta, and then you plug 0 d theta, and we still need to do from 0 to pi over 4. Now, instead of r, plug 2 cosine theta, so it'll be 2 cosine theta cubed over 3 sine theta minus plug 0 is 0. And then d theta. So the 2 cubed is 8, so the constant is 8 over 3. And we have cosine cubed sine theta d theta. This is done u substitution. U is cosine theta, and du minus sine theta d theta. Get rid of the number. Minus du is sine theta d theta. So the constant is 8 over 3. Cosine, that's u cubed now. And sine theta d theta is minus du. So you put du and a minus outside. The integral of this is u4 over 4 minus 8 over 3. So it becomes minus 2/3 u to the 4, which is cosine to the 4 theta. And you're between the two limits, pi over 4 and 0. Minus 2/3 cosine pi over 4 to the power 4 minus 2/3 cosine to the 4 of 0. Now you know that this is 1 over root 2. 1 over root 2 to the power 4 minus plus 2/3. Cosine 0 is 1, and 1 to any exponent is 1. So now this 1 squared is 1. Root 2 squared becomes 4. So this times 1/4 plus 2/3, because 1 to any power is 1. So you have negative, this is negative 1 over 6, if you write it, and this is 4 over 6, and the answer would be 3 over 6 half. So the answer of the question after all of this is half. Good? There's one more question in this worksheet. Integral x squared plus y squared 7 over 2 dA, where d is the unit circle. So if it's a unit circle, if you want to sketch and it's the unit circle, so now I know radius is 0 to 1. He tells you in the question, use the method you find easy. The easiest way to do this is by polar coordinate. That's the easiest way to do it. Because remember, x is r cos theta, y is r sin theta, and x squared plus y squared is r squared. And dx dy, which is also the area, as r dr d theta. So we can say that we're integrating this is r squared to the power 7 over 2, and d8 is r dr d theta. We're doing the r first, and the radius is from 0 to 1. We can again, it's easier to do this portion from 0 to pi over 2 times 4. Because this would be a quarter of a circle, just do this times 4. Now, when you raise to exponents, you multiply the exponent. So 7 over 2 times 2 becomes 7. When you raise to multiple exponents, you multiply the exponents. Times r dr d theta. This is r to the power 8 dr d theta. So now we can integrate this with respect to r. So it's r to the 9 over 9, 0 and 1 d theta, and the theta is between 0 and pi over 2, 4. Now you plug the 1, that's 1 over 9, 1 to the 9, which is 1, minus 0 to the 9 over 9, that's d theta, 0 to pi over 2 and 4. So this is basically integrating 1 over 9 d theta. And the integral of this would be 1 over 9 and a 4, so 4 over 9 theta. From 0 to pi over 2. Flux pi over 2, flux 0, so that becomes 2 pi over 9. This is worksheet A. I haven't looked at worksheet B because of time. I don't know when do you actually have to hand this in, but because he posted it late, I thought that we'll do A, and then B we'll probably review again when it's exam time. I did my best. I was trying to do this as quickly as possible, so hopefully I didn't do any mathematical mistakes or anything. Anyways, it's not hard stuff. You can handle it. So we'll see you again when it's the next one. Bye now.